about how to read a solubility curve. So here's one right here. It looks pretty scary, pretty involved, but once you actually dive into it, it's really not that bad. If you look at the y-axis, it says solute per 100 grams of H2O. So what this means is how many grams can 100 grams of water hold of any one of these substances. So you have a different line for every different substance, and it's talking about exactly how much 100 grams of water can hold. Now, what do I mean by hold? Because that is terminology that I use a lot. It actually means can dissolve. So if a solute is dissolved in water, we say that water is holding it, okay? So let's just look, now down here is temperature. We learned about exactly how temperature can affect solubility. Do you remember for solids, as we increase temperature, we're going to increase solubility, okay? So we look here at the solids. Ki, NaNO3, potassium nitrate, we've got NH4Cl. Do you see how as we increase temperature, those are increasing as well? They all have positive slopes because as the temperature goes up, so does solubility, okay? But now let's find a few here that actually have a negative slope. We see there's one right here, that's HCl, hydrochloric acid. We've got one right here, that's NH3, ammonia. And we've got one right here, SO2. You see, all three of those are actually gases at room temperature. And if you remember, I always think of soda. As you increase the temperature, gases become less soluble. That's why those three are decreasing as we increase the temperature. So you can look at one of these graphs and you can point out all the solids and all the gases. If they're positive slope, it's going to be a solid. If it's a negative slope, it's going to be a gas. Okay, so what are you actually going to be asked on the quiz or test? Here's an example here. So let's go ahead and take some time to answer these questions using the graph. Which substance has the highest solubility at 10 degrees Celsius? Okay, now we come back here. 10 degrees Celsius is where we need to go. Okay, now if you look, here's the lowest one. So at 10 degrees Celsius, water, 100 grams of water, can hold only about 7 grams of potassium chlorate. So that is actually our lowest one. To get to the highest, we have to go all the way up to the top, and there it is. At 10 degrees Celsius, 100 grams of water can hold 136 about grams of potassium iodide. That means that this is the most soluble. It has the highest solubility at 10 degrees Celsius. So our answer here would be potassium iodide. Okay, let's look at the next question. How much KCl can 100 grams of water hold at 50 degrees Celsius? Okay, so we're talking about 50 degrees Celsius. Now this time we're specifically looking for KCl, okay? KCl is right there. So we come down to 50. This is the maximum amount that 100 grams of water can hold. So I would say about 42. About 42 grams is the maximum amount that 100 grams of water can hold at 50, okay? So our answer would be 42. Don't forget that we do need a unit. We do need a unit, so make sure you always answer this with a number and a unit. Okay, now I'm going to change this number slightly, okay? This question. Question number 2, I'm going to change just this right here to a 3. So now let's see what this question's saying. How much KCl can 300 grams of water hold at 50? Do you see our big difference here is how much water? Okay, 42 grams, so at 50 we go up to KCl, and we have 42 grams. That's for 100 grams of water. We want to figure out exactly how much 300 grams of water can hold. Do you see the difference here? This is 3 times larger than this. So what do you think we need to do to the 42? Yeah, we're going to multiply it by 3. 3 times 42. And that's where your answer would be, which would end up being 126 grams. And there's your answer. Okay? So do always look and see exactly how much water we have. It might not be 100. The graph tells us if there's 100 grams, but the problem might be asking for a different amount. So always look for that amount of water and see if you're going to have to do some extra math. Okay? Let's do the last question here. If a solution contains 100 grams of sodium nitrate at 20 degrees Celsius, is the solution saturated, unsaturated, or supersaturated? Okay, so before we move on, we're going to need to remind ourselves of what those definitions actually are. So let's go back and look at those. Saturated is when a solution is holding the maximum amount of solute that it can hold. So our graph actually tells us the amount of grams at saturation. Okay, so if it's exactly on the line, that's going to be saturated. Unsaturated solution is any solution that is holding less than it could. So that means if we add more, it will dissolve because it's holding less than it actually can. Supersaturated is the one that's really crazy. It's a solution that is holding more than it should be able to. So over 100% of what it should be able to hold. So some of you might be thinking, how in the world would that happen? Well, here's how it's actually formed. What you do is you put in more solid that can dissolve at that temperature, and it's not going to dissolve. But do you remember what we can do to get more to dissolve? We increase the temperature. So if you heat it up, you can get more to dissolve. Now, technically, if you cool it down, then that would mean more would come out. But certain solids, if you cool them slowly, and you don't mess with them, sometimes you can get more solid to stay in, even though it's a lower solution. So at that point, it would be a supersaturated solution. Okay? Only a few solids can actually make this, okay? Not all solids can actually form a supersaturated solution with water. But what's crazy is once it's actually a supersaturated solution, all you have to do is add a little bit more solid, maybe bump into it, and all of a sudden, all of those solids are going to come out of solution. So they're not very stable. Okay, but let's go back to the graph now. We learned that saturated is exactly on the line, okay? Supersaturated is if it's holding more than it should. That would be above the line. Unsaturated would be below the line, okay? Because it's holding less than it should be able to. Just remember that the lines are saturated. So if it's exactly on the line, then it's going to be a saturated solution. Okay, so let's look at this question again. If a solution contains 100 grams of sodium nitrate at 20 degrees Celsius, okay? We're looking to see if it's going to be on the line, above the line, or below the line, okay? 100 grams of sodium nitrate at 20 degrees Celsius. So let's go to 20. Let's find sodium nitrate. It's all the way up here. Okay, so that's going to be right there. Okay, I think I have that right. Yep. So we're looking at 88 grams is the saturation. Okay? It is saturated if it's 100 grams of water is holding 88 grams, okay? But what is it actually holding? It's actually holding 100. Do you see that there's actually more in solution than it can possibly hold? There's more here than what it should be able to hold. So our answer is supersaturated. So there you have it. There are solubility curves and how to answer questions about it. Thank you.